Hello students, welcome back to my channel Experience Physics. And in this class, we will focus about the problems which involves non-uniform acceleration. Non-uniform acceleration. If the motion has non-uniform acceleration, this is coming under the chapter motion in a straight line. In our previous two videos, we have seen if uniformly accelerated motion is given, how to solve the problems. Right? In another video, if both acceleration and deceleration are given, how to solve them. The first one for uniformly accelerated motion. Second one, if both acceleration and deceleration are simultaneously given, how to solve the problem. This is mainly focused on if non-uniform acceleration is given, right? So for uniform acceleration, we use kinematic equation. That is, V is equal to U plus AT, S is equal to UT plus of AT square, and V square minus U square is equal to 2AS. So this list of kinematic equation, here the A and A, they are uniform. That means it is constant. If the acceleration is a variable or non-uniform, how to solve the problems? This is what we are going to solve in this video lecture. Of course, few problems we have uniform acceleration also. Let us see one by one. The two equations I will regularly use in the entire video. Only the two equations, they are fundamental, you know. V is equal to ds by dt. Velocity is equal to time rate of change of distance or displacement, right? Then A is equal to dv by dt. Acceleration is equal to time rate of change of velocity. These are the two equations we will need regularly to solve the problems if non-uniform acceleration is given, right? So let me go into the contents one by one. The first one, a particle starts from origin and moves along x-axis so that its position at any instant is 3t square minus 5t. Position we will write x is equal to 3t square minus 5t, where t is in seconds and x is in meter. Yes, t is in second and x is in meter. The acceleration of the particle, A of the particle, after 5 seconds, x is equal to 3t square minus 5t, right? So we can write v is equal to, so two steps we have to do. From x, find velocity, from velocity find acceleration. These two equations, very simple. So instead of s, we are having x, because x is given here, x is in meter, right? In some problems you will have s, in some problems you will have x. They are interchangeably used, no need to confuse. So v is equal to dx by dt, then a is equal to dv by dt. First I will use this equation for finding the velocity, then velocity is differentiated to find the acceleration. A is equal to what after 5 seconds, that is the question, right? V is equal to dx by dt. 6t, 3 is constant, 3 into 2t minus 5 is constant. Differentiation of t with respect to t is 1. So this will be 6t minus 5. Then differentiation of velocity with respect to time. 6 is constant. Differentiation of t with respect to t is 1. So it is a constant. So 6 minus 0. A is equal to 6. A is equal to 6 is the answer for this problem. The options are constant, 0, non-uniform, data insufficient. Constant is correct. A is equal to 6. 0, non-uniform. Non-uniform means it is not constant, variable. Next problem. A particle initially at rest moves along the x-axis. Its acceleration varies with the time as a is equal to 6t plus 5. So students, please remember, in most of the problems in this video lecture, we will have this type of data only. Equation format, not in the numbers. From the numbers, we have solved many problems in the video lecture number 1. The link is given in the description box. You can watch it if you are interested. If it starts from origin, the distance covered in 2 seconds is, see, the particle is initially at rest along the x-axis. Initially at rest means it is u is equal to 0. That is what it means. Its acceleration varies with the time as a is equal to 60 plus 5 meter per second square. If it starts from origin, the distance covered s is equal to what in 2 seconds. How long distance the particle would have gone? That is the question, right? So acceleration, from acceleration we have to come down to displacement, right? So we know v is equal to ds by dt and a is equal to dv by dt. A is given. From a we have to find v. If we integrate it, we will get v. Then from v we have to find s. These are the 2 steps we have to do. First, let us find what is the velocity. Step number 1, a is equal to dv by dt. We need velocity, right? In the first step, we need velocity, cross multiply it. So dv is equal to a into dt. Then both sides integrated. Integral of dv is equal to integral of a dt. A is given 60 plus 5. So I will write 6t plus 5 to dt. This is integral of dv. Integral of dv will give us v. Integral of 60 is 6 constant. T is written as t square by 2. Basic integration. T square by 2 plus 5 is constant. If we integrate a constant, the variable will come 5t. So this is 3t square plus 5t. This is velocity. From velocity, we have to find the distance, right? Like this, we will write v is equal to ds by dt. Similar steps, right? Cross multiply. ds is equal to v into dt. Then integrate. ds is equal to integral of v dt. Then put the value for v. V it is 3t square plus 5t. Integral of ds is yes, 3t square, 3 is constant, t square will give us t cube by 3 plus 5, t is constant, 5 is constant, t will give us t square by 2. So this is t cube plus 5 by 2 t square. This is s. The question is to find s in 2 seconds, right? Let us put t is equal to 2 cube plus 5 by 2 into 2 square. So this is 8, this is 5 into 2, 1, 2 will be cancelled. This is 8 plus 10. 18 is the answer. Option B. Next problem. The displacement of a moving particle is given by, displacement is given. X is equal to a t cube plus b t square plus c t plus d. The acceleration of the particle at t is equal to 3 seconds. A is what at t is equal to 3 seconds. So from x we have to go to v. From v we have to go to a. So v is equal to dx by dt. A is constant, 3t square. A is constant, 3t square plus b is constant, 2t plus c is constant. Differentiation of t will be 1. Then differentiation of a constant is 0. Then 3at square plus 2bt plus c. This is velocity. Then a is equal to dv by dt. 3a is constant, 2t differentiation of t square. 2b is constant, differentiation of t itself 1. So then it is 0. So this is 6at plus 2b. The question is at t is equal to 3 seconds. So put t is equal to 3. A is equal to 6at plus 2b. If I put t is equal to 3, 6 into 3 is 18a plus 2b. 18a plus 2b, that is the answer. Acceleration after t is equal to 3 seconds is 18a plus 2b. So 2 has been taken outside. So let us take 2 outside. So this is 9a plus b. This is the answer. So we have to modify the answer. 2 of 9a plus b, option B. Next problem, a particle starts from rest with a time varying acceleration, non-uniform acceleration, right? A is equal to 2t square minus 2, where t is in seconds and a is in meter per second square. Then the particle comes to rest after a time of, after time of t is equal to what? When the particle is coming to rest means its velocity is becoming 0. So we have to find the time when v is becoming 0. From a we have to come to v, right? A is given, the fundamental equation is a is equal to dv by dt. From this equation we have to find v, so cross multiply it. dv is equal to a into dt. So integral of dv is equal to integral of a into dt. Both sides are integrated. Integral of dv is equal to integral of a is 2t square minus 2 dt. So this will be v, 2 is constant, t cube by 3 minus 2t. So this is velocity. The velocity is going to be 0. So we have to make this right hand side is equal to 0. So 2 by 3 t cube, 2 by 3 t cube is equal to 2t, right? So 2t cube is equal to 2 into 3 t. So 1 t we can cancel out. 2 we can cancel out. So this is t square is equal to 3. T is equal to root 3 is the answer. Option C, root 3 second. So when t is becoming root 3, the velocity will be 0. Velocity of a particle is given by, the data is v is equal to 10 plus 0.2 t square. Then the particle is undergoing, velocity is given, then the particle is undergoing zero acceleration or uniform acceleration or non-uniform acceleration or uniform velocity. Zero acceleration, uniform acceleration constant, non-uniform variable, then uniform velocity. In the first three cases, it is acceleration. So let us first find what is acceleration. Uniform velocity will not be the right answer. Right. So let us find what is the acceleration. A is equal to dv by dt. So differentiation of velocity, this is 0, differentiation of constant. Then this is 2 into 0.2, 0.4 t. So velocity, acceleration is 0.4 t. So the time factor is coming, so it is a variable non-uniform acceleration. That is the right answer. T is coming. If it is just to 0.4, it is uniform acceleration. If it is just to 0.4, but 0.4 t. So when time progresses, A will be varying, non-uniform acceleration. Uniform velocity, definitely this will not be the answer. Yeah. The data itself they have given non-uniform, right? Right, next problem, the acceleration A of a particle starting from rest varies with the time t according to the relation A is varying kt plus c, where c and k are constants. The velocity v is what after a time t, after t seconds. So simple, A is equal to dv by dt, cross multiply it, dv a dt, integrate it, dv is equal to integral of a dt. So integral of dv is equal to a is given kt plus c. With respect to t, we are integrating, this will be v, this is k is constant, t square by 2 plus c is constant integrate, if you integrate it, it is the variable c into t. The velocity is kt square by 2 plus ct, kt square by 2 plus ct, kt square. So option B is correct, of kt square plus ct. Next problem, the displacement x of a particle varies with the time t as x is varying with respect to time as x is equal to a e power minus alpha t plus b e power beta t. So differentiation of exponential time you must remember for this problem, where a, b, alpha, beta are constants. A is constant, b is constant, alpha is constant, beta is constant. The time is the only variable. X is varying with respect to time only. The velocity of the particle will go on decreasing with the time, dependent on alpha and beta, drop to 0 when alpha is equal to beta, go on increasing with the time, right? The question is, we have to find what is the velocity. One equation will come, then we'll analyze the equation, right? The answer which suits the given options. Right? X is equal to AE power minus alpha t plus BE plus beta t. Velocity, find velocity. V is equal to A is constant, A, B, alpha, beta are constant. A is constant. So this is minus alpha t, e power minus alpha t. If we integrate, minus alpha will come here, e power minus alpha t. Right? Then B is constant. Similarly, here minus alpha, here beta will come, e power beta t. So this is velocity. So velocity equation is found. Go on decreasing with the time. Be dependent of alpha and beta. Drop to 0 when alpha is equal to beta. Go on increasing with the time. Right. So decreasing, first let us analyze what will happen to velocity if time is changing, time is increasing, right? So this term has negative power, exponential negative power, negative power. This term has exponential positive power, positive power. So t is increasing, so minus alpha t, alpha is also a constant, already it is given alpha beta, right? So alpha is a constant. When t is increasing, the negative power will decrease this value, right? So v is equal to minus, I am rewriting it, minus a alpha e power minus alpha t plus b beta e power beta t. This term, when t increases, t will always increase, right? We know it. When t increases, mathematically when t increases, this term will approach 0 because of this negative value, negative power. This term will go on increasing. When t increases, the first term will become 0 after some time because it is gradually reducing, but it is constantly, it is gradually increasing. The second term is gradually increasing. After some time, the first term will be vanished. It will become 0. There won't be the value for the first term. Only the second term will have some value that is increasing with respect to time. As time increases, as time passes, it will be go on increasing. So option D is correct. Go on increasing with the time. Next question, the displacement of a particle moving with a uniform acceleration in nth second given by Sn is equal to 0.4 n plus 9.8 meter. In the nth second, we don't know n is equal to what. Nth second, this is the relation. Find its initial velocity. U is equal to what? U is equal to what? Right. So to solve this question, you must remember this formula. Sn is equal to U plus of a 2n minus 1. Nth second, not n seconds. For n seconds, we will write S is equal to ut plus of at square from the list of kinematic equation. Not this formula, right? So we have derived this formula from this set of formula in the previous video, right? You can watch it, that video also. S suffix n, nth second, what is the distance covered in nth second? U plus of a 2n minus 1. So this is Sn is equal to 0.4n plus 9.8. We have to relate, we have to equate these two equations and we will get what is u. U is the question. Right. So let me separate them. Right. It is given in the bracket. No such term is available here. Right. Just by inspecting it, don't write u is equal to 9.8. It is not the right answer. You have to separate it. Term by term you have to separate it. Right. So u plus of a into 2n minus of a minus of a. So the 2 can be cancelled here. U plus an minus of a. So here there are 3 terms, but here are only 2 terms. Sn. So here there are only 2 terms. Here there are 3 terms. Only one term is having n in the product. Here there is no n, here there is no n, right. I will separate or I will write this way. Sn is equal to an plus u minus of a. So instead of a we are having 0.4. A is equal to 0.4. But the question is not about a. It is about u only, right? A minus of a. So u minus of a is in the place of 9.8. U minus of into a value is just found. 0.4 is equal to 9.8. So this is 0.2. So u is equal to 9.8 plus 0.2, that is 10. 10 is the answer. 10 meter per second. So with n, without n, they are separated, right? 2 terms, 0.4n, this is an. 9.8, this is u minus of a. This way we have to do it. Next question, a constant force acts on a particle and its displacement x in meter is related to the time t in second by the equation t is equal to square root of root x plus 3 square. This is how the displacement and the time are related. When the velocity of the particle is 0, when v is equal to 0, x is equal to what? Displacement is what? 1 meter, 4 meter, 5 meter, 0, right? So this is t is equal to square root of root x plus 3 square, right? The square root and the square can be cancelled, right? The square root and the square can be cancelled, right? This is cancelled. Or let me write it as this way. Square it. T square is equal to root x plus 3 square. Then take square root. T is equal to root x plus 3. That's all. These two will be cancelled, right? So t is equal to, this is the data actually. T is equal to root x plus 3 is the data. When the velocity of the particle is 0, we have to find the velocity, right? So find dt by dx. Differentiate time. Time is given, so differentiate time. So if you inverse it, dx by dt, that is our velocity. V is equal to, we know, dx by dt. So first to find what dt by dx, then you take the reciprocal. So root x plus 3, root x I will write x power of plus 3. So differentiate x power of x of minus 1 plus 3 is 0. Differentiation of a constant. So of x minus of is equal to of 1 by root x. X power of is root x, minus of will come down. So this is the velocity. Question is, the velocity of the particle is 0, right? This becomes 0. So I am sorry, this is dt by dx, we have to take the reciprocal. As I told, we have to take the reciprocal. This is not v. V is equal to dx by dt. That will be 2 root x, taking the reciprocal. This is velocity. So velocity is equal to 2 root x. V is becoming 0 when x is equal to 0. So v is equal to 2 root x. So if x is equal to 0, v will be 0. Option D. Next question, speed of a particle moving in a straight line varies with the time as v is equal to 3t square plus 2t meter per second. The distance covered in first 4 seconds. Distance covered in first 4 seconds is what? V is given. We know V is equal to ds by dt. Cross multiply, ds is equal to v into dt, integrate it. So we have to substitute this value. ds is equal to integral of 3t square plus 2t. So first 4 seconds. So we will put the limits 0 to 4. With respect to time only, we are integrating. So the time is varying 0 to 4. So this is s 3t cube by 3 plus 2t square by 2. It is 0 to 4. 3 and 3, 2 and 2, they are cancelled. T cube plus t square, 0 to 4. That will be s 4 into 4 into 4. So let me elaborately write. This is 4 cube minus 0 plus 4 square minus 0. This is 64 plus 16, that is. So let me write. So we can separate it and we are substituting the limits. 80 meter is the answer, option C. Next question, the velocity of an object moving in a straight line, path is given as a function of time v is equal to 60 minus 3t square, where v is in meter per second, t is in second. The average velocity of the object, is what? Velocity is given 60 minus 3t square. Average velocity between 0 and t is in question, right? Don't do it as I am first telling, right? First let me explain what you should not do. T is equal to 0, initial value. If you put t is equal to 0, 0 minus 0, 0. If you put t is equal to 2, 6 into 2, 12 minus 3 into 2 square. This is also 12. 12 minus 12 is equal to 0. So you will get 0 is the answer because it is instantaneous value. But the question is about average velocity. This is the equation, right? So we have to write the fundamental equation what we have studied earlier. Average velocity is equal to total distance covered between this time interval 0 to 2 seconds, how much distance the particle has covered, total distance covered, divided by total time, right? So total distance covered, we have to find the final s value minus initial s value. Initially where it was. Then similarly final time minus initial time, right? So yes, we have to first find yes. V is equal to 60 minus 3t square. V is equal to ds by dt. This is the expression. So ds is equal to V into dt. Integral of ds is equal to integral of V dt. S is equal to, it is 60 minus 3t square dt. So 6 into t square by 2 minus 3t cube by 3. So this is 3t square minus t cube. This is yes. So it is 0 to 2 second. I am sorry, I have not written the limits. 0 to 2, 0 to 2, 0 to 2, yes. So this is 3t square, 0 to 2 second, the limits must be written. S is equal to 3t square 0 to 2 minus t cube 0 to 2. 3, 4 minus 0 minus 2 cube minus 0. This is 12 minus 8. This is 4. So distance covered in 2 seconds is 4. So here 4 minus 0. Final distance 4. Initial it is 0. So SF minus SI will be 0. That is what we have found using the limits. TF minus TI 2 seconds. 2 minus 0. So this is 4 divided by 2 is equal to 2. The answer is option D. So please remember, for average velocity you have to write the fundamental equation and find the distance using these expressions, right? Next problem. A body travels for 15 seconds starting from rest with constant acceleration. If it travels S1, S2 and S3 in the first 5 seconds, second 5 seconds and the next 5 seconds, right? It is traveling first 5 seconds S1, second 5 seconds S2, then third 5 seconds S3, S1, S2, S3. For each distance S1, S2, S3, it is taking 5 seconds, 5 seconds, 5 seconds. So totally it is 15 seconds. This is given. The relation between S1, S2 and S3 is what? S1 is equal to S2 is equal to S3. 5 S1 is equal to 3 S2 is equal to S3. S1 is equal to 1 by 3 S2 is equal to 1 by 5 S3. S1 is equal to 1 by 5 S2 is equal to 1 by 3 S3. Logically you will find the answer immediately, right? This is constant acceleration, not deceleration. So if a particle is given an acceleration, its speed will go on increasing. For every moment, for every second, it will go on increasing, right? So first time interval, it has some speed. In the next time interval, it will have more speed than the previous one. Similarly, in the third time interval, it will have more and more speed than the previous intervals, right? So the particle will go on increasing, the speed will go on increasing if constant acceleration, right? S1 is equal to S2 is equal to S3, wrong. 5S1 is equal to 3S2 is equal to S3. This is decreasing, right? So this is also wrong. S1 is equal to 1 by 3 S2. That means S2 is equal to 3 S1. If we cross multiply it. If we cross multiply it, S2 is equal to here. S2 is equal to 3 S1. Then if we cross multiply S1 and S3, S3 is equal to 5 S1. So this is correct. Here S1 is equal to 1 by S2 is equal to 1 by 3 S3. So it is S2 is equal to 5 S1, S3 is equal to 3 S1. It is decreasing. The value is decreasing. So this is wrong. So logically you can find the answer. But anyway, let us check 1 by 3 whether it is 1 by 3 whether it is 1 by 5, right? So this is the line of path. First 5 second, next 5 second, next 5 second, 0, 5, 10, 15. This is S1 and this is S2 and this is S3. S1 is equal to, starting from rest, so u is equal to 0, ut plus half at square. Since u is equal to 0, let us write half at square. So S1 is equal to half a, what is t? 5. So 5 square is 25. This is 25 by 2a. Okay. Then S2. S2 is equal to, from, so this is S2. S2 is equal to the total time minus this one, right? Okay. So S2 is equal to half a, total time is 10 square minus this distance. S2 is the time interval, not from the beginning, not from the beginning. So I have to subtract this value to find this only, right? So this is 25 by 2a. So this is 100 by 2a minus 25 by 2a. So 75 by 2a. This is S2. So this is 75 by 2a, this is 25 by 2a. So S2 we can write 3 times of S1. S2 is equal to 3 times of S1. S2 is equal to 3 times of S1. If you cross multiply, S2 is equal to 3 times of S1. This is coming. So let us check the S3 also. S3 is equal to half a. This is 15 square minus this distance. So this is the total distance after 15 seconds. So this interval I need. So this distance has to be subtracted. This distance is 75 by 2a. So this is 15 square is 225. 125. 15 square, yes, 225 minus this distance, 75 by 2. 225 minus 15 is equal to, this is, somewhere I have missed, S2 is equal to 100a. This is not 75, this is S2. So this distance is 100 by 2a. I have to write 100 by 2a, I am sorry. Yes. The total distance is 100 by 2a. Then it is 125 by 2a, S3. 125 by 2a. 25 by 2a is S1. So S3 is equal to 5 into S1. S3 is equal to 5 into S1. So this is also true. So logically you can arrive at the answer, right? No need of making this much of calculations, right? For positive acceleration, for acceleration, it will go on increasing, right? Look at the option. Which equation is increasing? S1, S2, S3, that's all. Next question. The motion of a body is given by the equation dv of t divided by dt is equal to 6 minus 3 v of t, where v of t is the speed in meter per second at time t. If the body was at rest at t is equal to 0, at t is equal to 0, it is at rest. The magnitude of the initial acceleration. So a, when t is equal to 0 is what? Initial acceleration means v is equal to 0, The body, if the body was at rest, look at the question, if the body was at rest at t is equal to 0, at t is equal to 0, v is equal to 0, v is equal to 0, at t is equal to 0, a is equal to what when v is equal to 0 or t is equal to 0? That is the question, right? So dv of t by dt, differentiation of velocity is a. So in the data it is nothing but a only. A is equal to 6 minus 3 v of t. At t is equal to 0, v is equal to 0. Put v is equal to 0 here. So a is equal to 6 only. The answer is a is equal to 6. 6 meter per second square. So next question. A car moving at a speed v is stopped in a certain distance. A moving car is stopped at a distance when the brakes produce a deceleration a, right? The car is stopped. It is moving with a velocity v. That means initial velocity is v, final velocity is 0, right? It is stopped. If the speed of the car was n into v, what must be the deceleration of the car to stop it in the same distance? First, the car is moving with the speed v, initial speed. For case 1, 2 cases we have to take. Initial speed, final speed, it is to be stopped. Second case, initial speed, final speed. Initial, final. Acceleration, first acceleration, deceleration is a. Then what is the deceleration value for the second case? In both the cases, s is same. So we have to write the equation s is equal to ut plus, no, time is not at all given here. So this equation will not be used. V square minus u square is equal to 2as. So this is a constant deceleration. Same car, same distance, but the speed is different, right? So v square minus u square is equal to 2as. From here let me write s is equal to, in both the cases final is 0, final speed is 0. So it is 0 minus u square is equal to, let us write the equation separately, right? Let me write them separately. So s is equal to v square minus u square by 2a. So s is equal to, first case v square 0 minus u square is v divided by 2a, right? First case, final speed is 0, it is stopped. Initially it is coming by a speed v, the acceleration is given as a. For the second case, let it be no, because in both the cases s is constant. Second case, 0 minus n square v square, the speed is nv. So nv square is n square v square divided by 2a dash. For the second case, I am writing dash, right? So the 2 is taken here. The minus also can be removed. A square into v square is equal to n square v square. Cross multiplication. Minus is removed, right? Not a square, it is a dash. A dash into v square is equal to n square v square into a. So v square is removed. So a dash is equal to n square a. That is the answer. A dash is equal to n square a, option C. Right. The distance is same. So I am writing this equation for the distance. Final speed, initial speed. Final is 0 in both the cases. 0, 0. Right. Initial speed in the first case it is v. In the second case it is n into v. A is given. A dash is asked. Next question. A particle moves along a straight line such that its displacement at any time t is s is t cube minus 6t square plus 3t plus 4. Velocity when the acceleration is 0 is what? V is what? When A is 0. Acceleration is becoming 0. S is given in equation format. V is equal to what? So, V is equal to ds by dt. We will find by differentiating S. 3t square minus 12t minus 3. 3t square minus 6 is constant, 2t, 12t plus this is 0, right? V is equal to 3t square minus 12t plus 3. Then find A. A is equal to dv by dt. 6t minus 12. A is equal to 0. It is given. A is equal to 0. From here we will find what is t. Then if we put t here, we will get the answer. A is equal to 60 minus 12, that is 0. So 60 is equal to 12. T is equal to 2. If I put t is equal to 2 here, we will come to the answer. V is equal to 3t square minus 12t plus 3. T is equal to 2, right? A is becoming 0 at t is equal to 2. When t is 2 seconds, A is 0. So we are finding what is the velocity at that particular time. 3 into 2 square minus 12 into 2 plus 3. It is 12 minus 24 plus 3. 12 minus 24 minus 12 plus 3 is minus 9. Minus 9 is the answer. Option B. Right. Next question, in a straight line motion, the distance traveled is proportional to square root of time taken. Distance is proportional to square root of time taken. The acceleration of the particle is proportional to what? A is proportional to what? So practically S is proportional to t square only, we know. S is equal to ut plus of at square. So S is proportional to t square. For constant acceleration, if you assume the particle is at rest initially, so this is 0. For constant, of A is constant, so S is proportional to t square. This is the practical case, but in the question, the examiner is asking us to assume S is proportional to root t. Then A is equal to what? The acceleration of the particle is proportional to what? Right. First we will have to find V. V is proportional to what? Then from V, A is proportional to what? S is equal to dV by dt is proportional to root t. Let me write it as t power of, right? For easy differentiation, right? So root t I am writing as t power of. T power of is differentiated. Sorry, here it is S. V is equal to ds by dt. So differentiation of this t power of is of t power of minus 1. So this is of t power minus of. So this is of can also be taken removed because it is proportional, not equal sign. So V is proportional to t power minus of. T power minus of. Then A is proportional to what? A is equal to dV by dt. T power minus of. So this is proportional to minus of t minus of minus 1 power. Minus of minus 1. So this is proportional to minus of t power minus 3 by 2. So A is proportional to, this can be also removed. A is proportional to t power minus 3 by 2. This 3 by 2 can be written as t power minus of t power minus of t power minus of. T power minus of is velocity. So V cube. The answer is V cube. So S is proportional to root t. If S is proportional to root t, v is proportional to t power minus half, then acceleration is proportional to v cube only. So next problem, an object moving with a speed of 6.25 meter per second with a speed of, so initial velocity is 6.25 meter per second, is decelerated at a rate given by dv by dt. Decelerated, look at the minus sign, minus 2.5 root v, deceleration. So dv by dt is nothing but acceleration. Since it is having minus sign, it is deceleration. Where v is the instantaneous speed, the time taken by the object to come to rest would be when v is equal to 0. What is t? dv by dt is equal to minus 2.5 root v. So initial is speed is 6.25, final speed is 0, right? It is decelerated, right? So what is given? dv by dt is equal to minus 2.5 root v. V we have to find. Then we will substitute v is equal to 0, right? Let us find, right? So let us separate the variables, right? V we want to find, so we have to integrate it so that we will get v. If just v is given, we can make either differentiation or integration. But if differentiation is given, from the differentiation, how to find v? Integrate it, right? So before integration, let us separate the variable. Separating the variables, dv by root v. I am taking v here because this is v, this is also v. Then minus 2.5 dt. So velocities are coming one side, time is coming another side. So this can be written as v power minus half. Root v is half, since it is in the denominator, minus half. dv is equal to minus 2.5 dt. If we integrate it, we will get the value for v. So this is velocity v power minus half dv. Initial value is 6.25, final value is 0. So u is equal to 6.25, v is equal to 0. They are the limits. Is equal to minus 2.5 dt. The time is, initial time is 0, final time is t only, right? So integration, v power minus half, v power minus half plus 1 divided by minus half plus 1. Integration of v power minus half. 6.25, this is 0. This is minus 2.5, constant. Integral of dt is t only, 0 to t. So minus half plus 1, this can be written as v power minus half plus 1 is plus half divided by plus half. 6.25, this is 0. This is minus 2.5 t minus 0. Limits I have substituted. So this is, the 2 can be taken to the numerator. 2 of v power of 6.25 0 is equal to minus 2.5 t. So let me write here 2 of v power of, first we are putting 0 in the place of v, 0 power of minus 6.25 power of is equal to minus 2.5 t. We want the time when it is becoming 0. We want the time. So time I am going to take here. Before that we have simplified it. One more step I am writing, minus 6.25 power of is equal to minus 2.5 t. So the minus can be cancelled. T we need to find So T is equal to 2 into 6.25 power of divided by 2.5. Six 6.25 power of. So this is 2 into root of 6.25 divided by 2.5. So root of 6.25 is 2.5, right? So the answer is T is equal to 2 into root of 6.25 is 2.5 by 2.5. So these two are cancelled. T is equal to 2 seconds only. 1, 2, 2 seconds. So next question. The motion of a particle is described by the equation V is equal to A into T. The distance travelled by the particle in first 4 seconds. First 4 seconds. S is equal to what in 4 seconds? Easy. S is equal to V is equal to ds by dt. ds is equal to V into dt. Integral of ds is equal to integral of V dt. Then S is equal to first 4 seconds means we can substitute the time here. This is 0 to S. So this is S only. V I can write as 0 to 4. V is at dt is equal to A into t square by 2, 0 to 4. This is A into 16 by 2 4 square minus 0. This is 8A. 4. If we substitute t is equal to 4, 16. 16 by 2. So the option C is correct. Next question. An object starts from rest. From rest it is starting. On a smooth horizontal plane, then the ratio of displacement travelled by the object in nth second and n plus 1th second, right? So already we have found one formula, Sn is equal to u plus of a 2n minus 1, this formula. Nth second, distance covered in nth second, this formula will be used here. Nth second and n plus 1th second. From here you put n is equal to n first case, then n is equal to n plus 1 second case, right? So the ratio Sn is equal to, it is initially 0 from rest. So this is rest means, let us write of a 2n minus 1 only. This is for Sn. Then Sn plus 1 is equal to of a, instead of n, let me put n plus 1 minus 1. So this is of a 2n plus 2 minus 1. So this is of a 2n plus 1, 2 minus 1, right? So the ratio we have to find. Sn divided by Sn plus 1 of a of 2n minus 1 divided by of a of 2n plus 1 of a 2n minus 1 divided by 2n plus 1. 2n minus 1 divided by 2n plus 1. Option C. Next problem. If the displacement of a particle varies with the time as x power of is equal to t plus 3 by 2. X power of is equal to t plus 3 by 2. the velocity of the particle is inversely proportional to t. So we have to find the correct answer. Correct. Velocity of the particle is inversely proportional to t. Velocity of the particle is directly proportional to t square. Velocity of the particle is proportional to square root of t. The particle moves with constant acceleration, right? So fourth one is talking about acceleration. The first three are talking about velocity only. So let us find the velocity first. V is equal to dx by dt. This equation we will try first. X power of. So we will write, if we square it, x power of is root x. Root x is equal to t plus 3 by 2. Let us square it. X is equal to t plus 3 by 2 square. Dx by dt we will find. Dx by dt is equal to 2 times of t plus 3 by 2. 2 minus 1 is equal to 1. So dx by dt is velocity. Velocity is equal to, let us expand it, 2t plus 2 into 3 by 2 is 3 only. So v is equal to 2t plus 3. So v is proportional to t. The answer is v is proportional to t. But velocity of the particle is inversely proportional to t. Wrong. Directly proportional to t square. Wrong. Velocity of the particle is proportional to square root of t is also wrong. Velocity of the particle is proportional to t only. Option D is right. Let us check by finding the acceleration also. V is equal to 2t plus 3. So A is equal to dv by dt. If you differentiate it, d by dt of, instead of v I am writing 2t plus 3 is equal to A is equal to 2. Differentiate it. So A is equal to 2 is the answer. The particle moves with constant acceleration is correct. A particle located at x is equal to 0 at time t is equal to 0 starts moving along with the positive x direction with a velocity v that varies as v is equal to, v is varying as v is equal to alpha times root x. The displacement of the particle varies with time, s and t relationship. How the displacement is varying with respect to time, right? V is equal to alpha times root x. V is equal to dx by dt. This v can be written as dx by dt. Alpha times root x. We need to find dt. Dt is in differentiation form, so we have to integrate it. Before that, let us separate the variables. Dx divided by root x is equal to alpha times dt. Dx written here, root x, x power minus half is 1 by root x, right? Then dx is equal to alpha times dt. So integration of x power minus half dx is equal to alpha times dt. This is x power minus half plus 1 divided by minus half plus 1 is equal to alpha into t. This is x power plus half divided by plus half is equal to alpha t. This 2 can be taken here. 2x power of 2 is going to numerator. 2x power of is equal to alpha t. So I am writing 2 root x is equal to alpha t. The relationship between s and s, not s, x, right? Displacement x. So this is 4. If we square it, 2 square is 4, root x become x, and alpha square t square. Then x is equal to alpha square t square by 4. Then x is proportional to t square only. Since alpha is constant, 4 is also constant. X is proportional to t square only. T square option A. The next problem, the displacement x of a particle at the instant when velocity v is given by v is equal to square root of 7x plus 25. Find its acceleration and initial velocity. Find its acceleration and initial velocity, right? So v is given, a is equal to dv by dt. If we use this formula, a is equal to dv by dt, differentiate it, we will get acceleration. But initial velocity is also asked, u, right? So if we differentiate it, we will get acceleration only. Initial velocity, how to find initial velocity, right? If you look at the answers, A. In all the 4 options, A is constant. That means kinematic equation can be used for this problem. Kinematic equation, right? We can use kinematic equation, right? Let me explain it. V is equal to square root of 7x plus 25. Square it. V square is equal to 7x plus 25. The equation, kinematic equation without time, V square is equal to U square plus 2AX. So V square is available, U square is 25. We will rearrange it. 25 plus 7x, that is V square is equal to 5 square plus 2 into 3.5x. So U is equal to 5, A is equal to 3.5. U is equal to 5, A is equal to 3.5. U is equal to 5, A is equal to 3.5. Option B, right? So we are comparing this equation by writing the kinematic equation, very simple. Next problem, the relation between time t and the distance x is t is equal to ax square plus bx, where a and b are constant. A and b are constant. The acceleration is a is what? T is equal to ax square plus bx. Acceleration is given, right? So first let us find dt by dx. Differentiate it. So if we inverse it, taking the reciprocal, we will get dx by dt. That is the velocity. After finding the velocity, we will come to find what is acceleration, right? So dt by dx is equal to ax square plus bx. So 2ax plus b. Then v is equal to reciprocal of dt by dx. Dx by dt is equal to 1 divided by 2ax plus b. Velocity is now available. We have to find a. So a is equal to dv by dt. So differentiation of this. This can be written as 2ax plus b power minus 1. It is taken to numerator by having the minus 1. So dv by dt minus 1 of 2ax plus b minus 1 minus 2 into 2a constant into x differentiating x dx by dt plus b, differentiation of any constant is 0. This constant is coming along with x. That is why we are differentiating it. Just if it is 2a, we will easily make it as a 0. Differentiation of 2a will be simply 0, right? So this will be minus 1 divided by 2ax plus b square. Minus 2 is coming down as plus 2, minus 1, yes. 1 divided by 2ax plus b square. So this will be 2a. This dx by dt is, here it is available. Dx by dt is 1 divided by 2ax plus b. This is 2ax plus b square. This is 2ax plus b. So I am multiplying these two. So a is equal to minus 1 divided by 2ax plus b square. This is also 2ax plus b. 2ax plus b cube. Then another 2a is available. 2a. This 1 by 2ax plus b, the power cube. 1 by 2ax plus b. This is nothing but v. v is equal to 1 by 2ax plus b. 1 divided by 2ax plus b cube. So this will be 1 divided by this is 1 divided by 2ax is v. So this will be v only. Minus v cube 2a. Minus v cube 2a. Minus v cube 2a. Option C. A is equal to minus 2a v cube. Yes, this is the last one. In the one-dimensional motion of a particle, the relation between positive x and time t is given by x square plus 2x plus t is equal to t. X square plus 2x is equal to t. Here x is positive number. Choose the correct statement. What is given? X square plus 2x is equal to t. The retardation of the particle, negative acceleration, the uniform velocity of the particle, both are correct. Retardation and velocity. Both means velocity and acceleration. Both are wrong. Velocity and acceleration. This value is wrong as well as this value is wrong. This is what option C and D are telling. Right. What is given? X square plus 2x is equal to t. Displacement versus time is available. First we will find what is velocity. From velocity we will find what is acceleration. Right. First we will find what is velocity. Let us check whether the coming answer is matching this value. So let me write it as t is equal to x square plus 2x. Velocity dx by dt, but directly we can't get dx by dt. dt by dx we can find. dt by dx. This is 1 by velocity 2x plus 2. So here v is equal to reciprocal of this value. V is equal to dx by dt is equal to 1 divided by 2x plus 2. Now velocity is available. The uniform velocity of the particle is wrong. The uniform velocity of the particle is wrong. We are having 1 divided by 2x plus 2, but it is 1 divided by x plus 1 power 3. If it is wrong, C also wrong, D also wrong, because both are correct, both are wrong. Correct means this must be correct. So option D, let us check. Yes, option D, let us check. Find the acceleration. A is equal to dv by dt. Velocity is 1 divided by 2x plus 2. 1 divided by 2x plus 2 is written as 2x plus 2 power minus 1. Right? 2x plus 2 minus 1. So differentiate it. Minus 1 of 2x plus 2 minus 1, that is minus 2. Differentiation. Minus 1 power. Then it is 2, a constant and a variable, both are coming. Please remember, the constant and a variable is coming. We have to differentiate this term also. 2 of dx by dt. Then this constant will be 0. Differentiation of 2 will be 0. Right? Let me write it as minus 1 divided by 2x plus 2 square. Minus 2 is coming as plus 2 in the denominator. Then it is 2 of velocity. Dx by dt is nothing but our velocity. That is 1 divided by 2x plus 2. 1 divided by 2x plus 2. So this is 2x plus 2, the whole square, it is 2x plus 2 only, right? 2x plus 2 the whole square, it is 2x plus 2 only. So cube A is equal to minus 1 into 2 is 2 divided by 2x plus 2 power 3. That is our acceleration. The retardation of the particle is 1 divided by 4 of x plus 1 power 3. So it is 2 only. Let us cancel 2 here. So minus 2 divided by 2 can be taken outside. If I take 2 outside, x plus 1 will be coming inside the bracket. X plus 1. This is 2. Since it is power 3, this will also be power 3. Right? Then it is 1, 2 can be cancelled. It is 2 square. So this is minus 1 divided by 2 square is 4 of x plus 1 power 3. Minus 1 divided by 4 of x plus 1 power 3. The retardation of the particle is 1 divided by 4 of x plus 1 plus 3. Yes, true. This is correct. Minus sign is for retardation, negative acceleration, right? So this is the end of the video lecture, guys, right? Thank you for watching. Good luck.